For this experiment, we first had to make Wheatstone bridge circuit using LT-SPI software. After this was done, we would set the voltage source to 10 volts and set the resistance values to the ones assigned to our group. Then we calculated the R4 using the principles from Kirchhoff's laws, as seen on the calculation part of the video. Once this was all done, we turned on the circuit. We then used the measuring probe of the software to see when the circuit would be balanced. One of the purposes of the experiment is to demonstrate the operating principles of Wheatstone bridge circuits. Loops and nodes can be observed in a bridge circuit. Loop is any continuous connection of branches that allows tracing of a path that leaves a point in one direction and returns to the same point from another direction, without leaving the circuit. On the other hand, a node is a junction of two or more branches, where a branch is any combination of series elements. The experiment also aims to illustrate the different conditions arising from the resistance bridge and its practical application, and to familiarize the students with the analysis of basic bridge used for instrumentation. We are in the theory part of the experiment. The theory behind this experiment is that it is possible to make accurate measurements when the negligible resistance of the ammeter and the negligible current in the voltmeter do not hold through the circuit called the Wheatstone bridge. It is a circuit of four resistors and is used to find an unknown resistance by using the known one. In the circuit, resistors 1, 2, and 3 are assumed to be known, while resistor X is the unknown resistance. The value of the resistors are adjusted until the galvanometer that is connected at point A and B indicates zero current, and when this occurs, the bridge is said to be balanced. At the balance, the unknown resistance is determined with the precision of the known resistance 1, 2, 3. Also, the resistance of a wire is directly proportional to the length of the wire, while it's inversely proportional to the cross-sectional area of the wire.
For the sample calculations, in finding the value of the resistor 4 or R4, we will use the voltage division rule, and afterwards, it can be simplified as R4 is equal to R2 times R3 divided by R1. After creating the equation, the given values such as R1 is equal to 60 ohms, R2 is equal to 40 ohms, and R3 is equal to 15 ohms will now be substituted to the equation, and it will now become R4 is equal to 40 ohms times 15 ohms divided by 60 ohms, and R4 will be equal to 10 ohms.
Now, we are gonna run the simulation of the Wheatstone bridge circuit using the calculated 10 ohms from our calculation. We're going to put the value 10, then run the simulation, and know that VA minus VB will be equal to 0. There, we got 0 volts.